In order to test the pitch variable oscillator and the volume oscillator of the Theremin we are building, we will need to connect them to their respective antennas. The antennas on the other end need to be held in place by a non-conductive structure to avoid changing their capacitance. Because of that, it seems just right to proceed now to the construction of these elements. The antennas will be built out of a copper pipe, while their holder will be embedded in the top section of the Theremin box. Let's see how that could be done. Hi there! I am Carlo Carrano, and this is Electronics Engineering Made Easy. We started with the construction of the box cover of the Theremin. Like the bottom section, I created this top section with my 3D printer. You can see on the left how the OpenSCAD code looks like. Once I defined the main sizes of the top box, I created it starting with a cubic shape, removing the excess plastic to obtain the basic structure of the cover, and then creating the holes where the antenna's holders will be located. Finally, I added some support to assure the rigidity of the walls of the cover, so it will not bend due to the weight of the antennas. The same supports will be later used to attach the bottom and top part together with some screws. And here is the final result, which you see upside down so it can be 3D printed easily. Please refer to the eleneasy.com website, where I am preparing a page where I make available all the files related to the Theremin. You can download the OpenSCAD file, this one, along with the resulting STL file that can be used to generate the G-code for the printer. In the same page, you will find all the other files from the previous episodes of the series. And here is my 3D printer in action to create the top box of the Theremin. Here is the OpenSCAD code for the attachments to the top box of the two antennas. The one for the pitch antenna is the big cylinder, while the volume antenna holder is the attachment with two cylinders. The code on the left is pretty simple, a cubic shape to support the cylinders and the hollow cylinders on it. And here is also the design of the second piece that is needed to complete the assembly of the pitch antenna. Remember, all the files related to these supports will be available on the eleneasy.com website. Once the attachments for the two antennas were ready, I glued them to the top section of the box with some hot glue. To hold the pitch antenna far away from the Theremin box, so to avoid interference with the volume antenna, I used a PVC pipe 19 inches long, with a section of the appropriate size to fit in the pitch antenna attachment that I built with the 3D printer. The PVC pipe was then painted in black to give to it a nice appearance. I printed the second attachment for the pitch antenna with a transparent plastic, but then I realized I really wanted it red, so I painted it as well. To build the actual antennas, I used some copper pipe, the kind normally used for hydraulic applications. Each antenna was made out of a length of 28 inches of that pipe. Here you can see how the volume antenna is supposed to be shaped. And here you can see how it is mounted on the top section of the box. And now the pitch antenna. First, we need to glue the copper pipe into the red attachment. Second, we need to attach to the antenna the inner conductor of a coaxial cable, long enough to go from the antenna through the whole PVC pipe and a few inches inside the Theremin box, so it can be electrically connected to the pitch variable oscillator. The coaxial cable on the antenna side is first attached to a metallic clip, soldering it to it, and then the clip is attached to the antenna itself inside the red attachment. Finally, the whole arrangement is attached to the top section of the Theremin box. And here is the finished product. I'll see you soon for the next Theremin video, and in the meantime, you know what to do.